Problem number 5. We're going to do some crashing in this example. So to do crashing, we need 4 columns of data. So normal time, crash time, normal cost, crash cost. Okay. Now we need to start with drawing the network. Using the normal time, find the project completion time. So first, this is a fairly simple network. So we start. There are 2 activities at the beginning. And remember, we're going to use the normal time first. And then after A comes C and D. And then E comes after B and D. F is after C. And G is after E. And that's the end. Now let's look at paths. To do crashing, we need path and path duration. So first is ACF, and then ADEG, and then BEG. The path durations are 4 plus 3 plus 3 equal to 10. 4 plus 8 plus 6 plus 4 equal to 22. 2 plus 6 plus 4 equal to 12. So that is our project completion time. Under normal time, and this is our critical path. So first question, what is the project completion time under normal time? So critical path ADEG project completion time is 22 weeks. Now the normal cost project cost with normal time is, okay, we need to sum this column, which is 12,300. So that's the basic cost. So under normal conditions, your project will take 22 months and the cost will be 12,300. But let's now see how to do crashing. Okay, so this is the normal condition, and let's go to the next page. Now here we are asked that we need to crash the project by 1 week. Which activity should be crashed and by how much? Okay. So first thing to do is to compute crashing cost per week. And so we take the difference between the normal time and crash time. Let's call that maximum crashing allowed, or maximum crashing possible. Okay. So that will be like for A it is 4 minus 3 is 1, and the cost difference is the difference between these two. 2600 minus 2000 is 600. Then crashing cost per week is you take the cost difference and divide by the maximum crashing allowed. So that is $600. You do the same for the rest of the activities. So 2 minus 1 is 2. 2800 minus 2200 is 600. So you get 600 over 1. It's 600. And 3 minus 3 is 0. So that means no crashing is allowed for activity C, or no crashing is possible for activity C. Activity D is 4 for MCA. Then we have 300 is the difference in cost. E is 6 minus 3, 1200 minus 900, so you get 300 over 3 is 100. 3 minus 2 is 1, so 4200 minus 3000 is 1200. Then 4 minus 2 is 2. 2000 minus 1400 is 600. And that's 300. Now remember, we have to only look at the critical activities. Okay. So first thing to do at this point, okay, is to identify the critical path activities. So critical path is A, D, E, G. So A, D, E, and G. So those are the activities you really should look at. And the minimum value here, so the activity to crash is critical activity. So that's important. You have to look at only the critical activities. Critical activity with the least crashing cost per period. In this case it's per week, and that is equal to activity D. $75 per week. Now, the next question is, how many weeks can activity D be crashed? Okay. So that is given by, this is important, again this is one of the things that students make mistakes. You have to look at two numbers and select the minimum. Okay. So MCA is 1, of course, because that tells us how many weeks of crashing is possible for. For D it is 4. But not only that, you need to look at that plus, okay, one more item is project completion time, that is the length of the critical path, minus duration of the second longest path. You have to look at these two things. So for activity D, then this is minimum of MCA is 4 and project completion time is 22 and the second longest path is 12. So 22 minus 12. So that is 4 weeks. So that's the amount of crashing we can do. So that's we have run out of space here, so we'll turn over and work from the other side. After crashing activity D by 4 weeks. Okay. So now we have to re-evaluate the path duration. So we have 3 paths, ACF, AD, EG and BEG. So these were the 3 paths. Now the new path duration, okay, so ACF remains the same like before, there is no change. ADEG will be 4 plus now D is only 4 weeks. So this is where we crash. So this is after crashing. And BEG, there is no change. 2 plus 6 plus 4 equal to 12. So the new project completion time is 18 weeks. Okay. The new project cost is, you have the old cost, which is 12,300. Remember we did that. Okay. So now we have crashed activity D by 4 weeks. So 4 weeks times $75 per week. Okay, we calculated that in the previous page. So D, cost of crashing per week is 75. So that is equal to 12,300 plus 300 is 12,600. Okay. Now if we are satisfied with 18 weeks, then we can stop here. If not, if we want to crash some more, then we have to repeat this process. So if you have to repeat this process, next activity to crash will be what? Okay, so going back here, now you see that D is already crashed all the way. So D cannot be crashed anymore. Okay, our critical path is still A, D, E, G. Now the choice is between A, E, and G. So the choice we have is A, E, and G. Okay, D is no longer available. So between A, E, and G, E has the smallest cost. So the next activity to crash is E at $100 per week. And we can keep going through this process until we run out of activities that can be crashed, or if we have reached the goal that we wanted to reach.